Okay, in this presentation we're going to look at complex numbers. Now, specifically what we're looking at is the Moivre's theorem. So the question is, write out 1 plus I to the power of 10 in the form x plus yi. Okay, so the first thing we have to do here is we have this in rectangular form there. Okay, and what we're going to do is write it in polar form. Okay, so what we have to do there is calculate the modulus or the magnitude and the argument. Okay, so we need to find r and theta. Now, r is essentially the square root of a squared plus b squared, where a is the real term and b is the imaginary term, the imaginary coefficient there. So 1 squared plus 1 squared, remember this is 1i. That gives us the square root of 2 when we add them up and get the square root of that. Okay, so the next part is calculate the argument, theta. Okay, so I'm just going to bunch that up there a little bit. Okay, so it's 1 plus I again. Okay, so the 1i over 1. Okay, so the imaginary coefficient over the real coefficient, and that gives us 1. Okay, so tan theta is going to be equal to 1. Okay, now what we have to do there is just check what theta would be in that case. So we have to get the inverse of tan of 1, and that would work out to be, on your calculator, pi over 4. Now it's important to actually just draw it out here like this, a little Argand diagram. Okay, now the reason is you have to just double check which quadrant it is in. So in this case, 1 plus I, so you just draw it out there, and this would be in the first quadrant, the top right quadrant. Okay, so in that case, so it'd be 1 plus 1i. Okay, so it brings us up there, so it's definitely in the first quadrant. Now in this quadrant, all of the tan, cosine and sine, they would be all positive numbers in this quadrant. So this is going to be a positive number here. So that's, just remember that, the ACTS component of this part of the question. So it's pi over 4 plus pi over 4 because tan is always positive in this quadrant. Okay, so 1 plus I is equal to the square root of 2 times cos of pi over 4, we're down here, okay, plus I sine pi over 4. So what we're going to do now is apply the Moivre's theorem. Okay, so 1 plus I to the power of 10, that gives us r to the power of 10, in this case the square root of 2 to the power of 10, times cos n theta, okay, n theta. N here is 10, theta is pi over 4, so we work that out, we get 5 pi over 2. Likewise, we get the same over here, 10 times pi over 4, 5 pi over 2. And working that out, that will give us 32. 32 times cos 5 pi over 2 plus I sine pi over 2. Now essentially, actually, we're nearly home. Essentially what we have to do is just evaluate these two terms here. I'm just going to pause it a second so I go to the next page. So I've just unpaused it there. So it's 32 cos 5 pi over 2. That actually, cos of 5 pi over 2 would work out to be 0. Plus I sine 5 pi over 2. Work that out in your calculator. It is 1i. So 5 pi over 2 is 1. So essentially what we end up with there is 0 plus 32i. So that is that job done. That is an introductory example of de Moivre's theorem.